Hello. We are going to delve into functions today. One of the kind of most important things so that you can actually have your code somewhat organized and prevent yourself from using duplicated code all over the place, which is a sign of one of the worst kinds of programming. So without further ado, let's do our first exercise, which is to write a program that contains a function called hello worlds, and it is going to print hello world a bunch of times. Okay, so this is exercise one. Okay, so we know exactly what the function is going to look like because it's already given us a name and a parameter. The parameter is my integer, and it is an integer. But what we also need is to figure out what will this function return. When it's done, what will it give back to us? And you might be tempted to think that this is going to give us back a string, but it is not. Despite it saying it's going to print out this message a whole bunch of times, it doesn't actually give us a string as part of its completion. It just, happens to print some things. But the fact that it prints something is irrelevant. When we have a return type for a function, that's because we want to do something like, for instance, if we had a function that said, square, and the whole point of the function was to give you a number and return that number times itself, that would actually need to have a specific return type of the same kind of number. But in this case, when we call the function, we don't actually want to change anything. All we want to do is just do some printing. So anytime you have a function that does not have a value you need to return, we say it is void. And in this case, we are going to call our function hello worlds. It's going to take my integer as a parameter, and we need to have braces to encapsulate all the code inside of our function. And what's it going to do? Well, it's going to need to have a loop because it's going to print out hello world. So, printing out hello world, we should know how to do. We'll do it with a new line character to make sure they're spaced out nicely. We want to do this a bunch of times. So at this point, again, you want to get very comfortable with the syntax for a for loop. So for loop, parentheses, braces, and then this printing is what we're going to do a bunch of times. And inside the parentheses is where we put the three different necessary components of the for loop. So the initialization, int I is 0, is very common. I less than the number of times you want it to run. How many times I want this loop to run? My integer. So I'll take that and put it there. And typically I++ is the most common increment that we're going to use. Now, I ran that and nothing happened, and I might be tempted to think, wait, did something go wrong? No, everything is okay, because all I have done is declared that a function exists. It's called hello worlds. It takes a parameter of an integer and then runs that loop. In order for it to actually go, we need to call it. So hello worlds, and let's say I want to print it out 10 times. So I write the name of the function, and in parentheses, I put how many times I want it to go. I can make this a statement, or I can make an expression. Making an expression won't do very much because I said that I don't want it to return anything. So there's really no difference. I'm just going to have a semicolon, and it prints out hello world 10 times, just as I like. And that's it. All right, so that's our first function. We'll move on to some more advanced ones. Okay, next exercise. Using the CMath library, write a function that shows whether the sqrt function behaves differently with integers and floats. Then figure out what the POW with parentheses base and exp function does. Then make your own function to do the same thing. So, making a new notebook. So in order to use a library, we need to include it. And so we use the keyword include and then CMath. And now we have access to all of the math library's functions, assuming that we knew what they are. If you don't know, you can always look them up. But in this case, we've been asked to use two specific ones, so those will be the only ones that I use. So the first one, sqrt, let's say that I want to take the sqrt of 4. It's 2.0000. The square root of, let's say, 4.5. And you can see what it's doing is just figuring out the square root, right? Now, I want to see, does it behave differently for integers or floats? Let's say I take 4.0 and 4. Looks like it's doing basically the same thing. How about something that doesn't have an obvious square root? Say the square root of 5 or 5.0. And so what we notice is that the square root function actually is defined interestingly in that it is always going to give us a floating point number as an answer, even if it takes an integer as a parameter or it takes a floating point number as a parameter. And this is something useful to know. Unlike when we did our division the other day with integer division, we saw 5 over 2 is 2 because they're all integers. We have to cut the decimals away. You can see here that even though we give it an integer as a parameter, it still can give us a floating point number answer. So just the way that this function works. Now let's try the other one. So we'll put in some numbers. Let's say 2 and 6. And so what we see here is that if you didn't already guess it, this is the power function. It's going to give us a base raised to a certain exponent. So for instance, 2 to the power of 10 is 1024. And so this function is doing that. Now, let's say that we wanted to write our own power function. Well, first of all, what is it going to take as a parameter and what is it going to return? Well, we can keep it simple for now. Let's just do the integer version. You probably could implement one that uses floating point numbers, but it gets a little bit more complicated. We'll call it power, and it takes an integer base and an integer exponent. To do this properly for all of the different kinds of variations on this, keep in mind that I could do 2.5 to the power of 10 as well, right? And this is valid in mathematics, and the power function from the math library allows us to do this. But if we wanted to write our own function, we might need to have one version of this for integers and another version that handles floating point numbers. But just to do one variation on this, we'll stick with integers exclusively. So, well, how do you figure out how to calculate a number raised to an exponent? Well, what we need to do is we start with a base. So let's think of an example. Say that we wanted to do 2 to the power of 5. 2 to the power of 5 is 32. But how does that come about? Well, 2 to the 5 is equal to 2 times 2 times 2 times 2 times 2. And so what we're doing here is that we're just basically taking our base and multiplying it that many number of times. So we want to have a variable to store our answer in because our answer is going to get modified as we calculate things. So our answer, and what's our answer going to start out as? It's going to start out as our base. Initially, 2 to the power of 1, the simplest example, is going to just be the number itself. But also keep in mind, 2 to the 0 is 1. So actually, our initial answer should start as 1 because it's possible that if we write a loop that's going to multiply by 2 over and over again, if that loop never runs, assuming that the exponent is 0, then we just want our answer to be 1. So our loop will go a number of times equal to our exponent. And each time it runs, it takes our answer and multiplies it by 2. We're doubling. So if I want to figure out what 2 to the 5 is, I start with a 1, and then I multiply it by 2 5 times. The first 2, multiplying by 2 once gives it 2, again gives it 4, 8, 16, 32. And then after I've done this calculation, I want to return my answer. And my answer is, my answer. Okay, so now the power of 2 to the 5 gives me 32. And 2 to the power of 10 gives me 1024, and so on and so forth. And so this is how you can implement one variation on this power function. However, keeping in mind that this one, because it's coming from a library, has a lot more things that are going on with it. It has some ways to optimize things to make things a little faster. As we can see, it also handles special cases such as floating point numbers. You can imagine that our version also doesn't work with negative numbers. If I have negative 2 to the 5, it's negative 32. But if I try to do that over here, will it work? Maybe it'll work. You see over here, it correctly figures out it's negative 32, but down here, it should realize that this, these answers don't quite match up, right? So these are just things to kind of keep in mind. Oh, also it's because I put 2, but it should be base. Wait a second, let's correct ourselves. Maybe this actually will work. Aha, it did. I caught myself before I made a very clumsy error. This was an example, but I obviously don't want to always just be multiplying by 2. I want to multiply by my base, because that way when I do something like 4 to the power of 3, it should give me 64. So it looks like our code will actually work with negative numbers for the base. It doesn't quite work for the exponent. 2 to the negative 2 is a quarter, because that's how negative exponents work, but our function is not going to do that quite correctly. Okay, it's just going to give us 1, which is wrong. So apologies for the clumsy little error I made, but luckily we caught it before the video wrapped up. So nice to notice those mistakes before I leave this unadjusted. Okay, so that was exercise 2. Let's move on to the next one. Okay, so see time. So unsurprisingly, computers are pretty decent at keeping track of time. We're going to use that to our advantage in this exercise 3. Okay, using ctime and using iostream, so those are there, write a program that prompts the user for a number, then generates and prints that many random numbers between 1,000 and 2,000. We'll need to use 3 different things to help us out. So first thing we're going to use is srand given the time. So what is this weird thing doing here? Basically, this is to initialize a random number generator. The computer is not actually able to truly simulate randomness. The best it can do is what we call pseudo-randomness. It's basically close enough for most purposes, but it's never perfectly random because a computer cannot be random. It is by definition very systemic, very, I wouldn't say objective necessarily, but it is very consistent in the way that it's going to work. And so in order to simulate randomness, we need to take something from outside the computer. And when you think about it, what's something that is kind of random, always changing, and never for certain? And well, it's what is the current time? So given the current time, we will set up our randomization so that every time we select a random number, it will actually be different. In that way, when I say random, it will give me an actual random number that's going to differ every time. And now, depending on when the time is, these random numbers can change. If you don't include this, sometimes you won't notice, but if you run the same program under the same circumstances repeatedly, the random numbers will no longer be random. You'll actually get the same random numbers every time, which kind of defeats the purpose. Anyway, so we've got our random number generator using the time. We want to prompt the user for a number, so this is where we're going to need to ask the user for something. So anytime you ask the user for something, you should always start out by, oh, I missed a semicolon here. There we go. Let's start out by telling them what you need. So, give me a number. And then to read in, we're going to need somewhere to put that number, so int their number. And to read in, we need to use std::cin, and then 2 arrows into their number. And this is something you may not have seen before, and we'll find other ways to write this as well, but this is being used just now so we can collect the user's number and store it in this variable. Okay, we need to generate and print that many random numbers. So first, let's also, before we even go any further, let's make sure this actually works. It's never a good idea to try to program everything and then run it. You should make sure that some parts of what you have are working already. So it correctly writes out, give me a number. It seems to prompt me for an answer. Let's say I put in 100. Is their number 100? Yes, okay, so everything is working okay so far. Now, we need to generate and print a bunch of random numbers. How many? Well, we're going to probably want to use a loop, and we're going to make it run equal to that number. So int I is 0, like we usually do. I less than their number, that's the amount of times I want it to run. I plus plus. And I want to print out a random number except I don't just want any random number, because if I do this, and I say, give me 5 random numbers. Whoop, what did I mess up? There's another pending input. Oh, okay, there we go. These are not between 1,000 and 2,000. So I need to figure out how to trim down these numbers from being gigantic into this actual range. And the first thing that will help me is the modulus operator. This will allow me to figure out the remainder of division, but what I actually want to do is give me values between 0 and 999. So now if I run this, and I say give me 5 numbers, you can see they're all between 0 to 999, which is not quite what I want, but we can get there, right? So 0 to 999, let's say that I add 1 to whatever that is. Now it's 1 to 1,000, which is getting closer. Now, I think I want slightly more than... I don't want just 1 to 1,000. I want technically 0 to 1,000, because that's going to be the number of values that are here. So instead of taking modulus 1,000, let's take modulus 1,001. Now the lowest number I can get is 0, and the largest number I can get is 1,000. So 10 is the lowest one I happen to get here, but I can get anything 0 to 1,000. If I add 1,000 to that, now all the numbers I get are at minimum 1,000, that's the smallest I can get, and the biggest I can get is 1,000 plus 1,000, which is 2,000. And so that's how I get the range I'm looking for. There's lots of different mathematics you can do with the random function to figure out how you want to randomly generate your values, but if I just care about having the exact same likelihood of any number in this range, I just need to know how many different values are possible, which in this case is 1,001. And what is the starting number, which in this case is 1,000. And there we have it. Right, on to one more exercise. Okay. Go back to the first program and overload the hello world's function to print a different greeting if the function is given an integer and 2 initials. Okay, so if we're going back to our first program, let's duplicate it. And this will be exercise 4. Okay, so this is our original function, and we want to overload it, meaning we want to make a new definition of it with a different set of parameters. So instead of an integer, we have an integer and 2 initials. So first initial, second initial. And we want to print out a different greeting. So instead of hello world, how about we say hello to %c.%c. Remember, these are the format specifiers for characters that we saw before. And here we'll put in that first initial and that second initial. And now when we call hello worlds 10, it'll print out hello worlds 10 times. But if we say hello worlds 10 m, it'll print out a different greeting. So just running these all together now. Oh, what did I mess up? Okay, good thing to note. And this is kind of Jupyter specific and something that I forget sometimes, which is that in Jupyter, you are not allowed to define a function in the same cell as another function. So as nice as it is to want to do this, you can't. And so the solution is simply, I will make a cell below, and this will be the othered version of the function. And now we should be able to run it all. There we go. So yeah, important note is in Jupyter in particular, you cannot put 2 functions in the same cell. Later on when we're working with different kinds of files, you can put them closer together, but you can never put a function inside of another function with one particular exception that we'll talk about later. And also when you're working in Jupyter, each function must be in its own cell. So now I have my 2 versions of the function. When I just call it with a number, it just says hello world 10 times. But when I call it with the number and the initials, it says the other message, because C++ is able to look at the parameters that you're given and figure out which version of the function is the appropriate one to be calling. And in this case, it sees this one has no initials, so it calls the first one. This one does have initials, so it calls the second one. And that's it. So hopefully this was a useful brief introduction to functions, and we will see some more in the next video. Take care.